In this section, we talk about the differential equation of equilibrium. Okay, look at a beam like this. Inside the beam, there is a material point. So we magnify the material point like this in order that you can see it clearly. The length of the material point is dx and dy here, dx. Okay, and inside the material point, there are some body force, Bx, By. What is Bx, By? Bx is the body force in the x direction. By is the body force in the y direction. What are the body force? The body forces. See, the body forces in the y direction usually come from the gravitational force. Okay. By usually come from the gravitational force, like a beam must be have a weight, okay, weight like 2,000 kilograms, something like this, okay. So By, the body force in the y direction, is usually the weight of the material point. How about the body force in the x direction? Usually we don't have body force, we have zero body force in the x direction. In some special case, when we consider the material point is subjected to some electromagnetic field, okay, for example, like the cell in your body, is affected by the electromagnetic field near you, then you may have some body force in the x direction, okay. But in general, for a beam in the civil engineering, we take Bx as zero and By as the weight. Okay, besides of this body force, what else acting on the material point? We consider at this surface we have a normal stress sigma xx right at the right side. The shear stress sigma yx in the right side. In the left, we have sigma x in the left, sigma yx in the left. Okay, so we have the shear stress, normal stress, shear stress, normal stress, shear stress, right? Also, in the upper side and the down side, up and down, we have the normal stress and shear stress, normal stress and shear stress, right? Now, this stress component and the body force components will be in the equilibrium state. Okay. Now there are two states. One is the vertical direction, the equilibrium state in the vertical direction. Another one is the equilibrium state in the horizontal direction. To simplify our job, we just consider one by one. I consider the horizontal equilibrium, and then you consider the vertical equilibrium equation. Okay, I show you how to write down the equilibrium equation in the horizontal direction, and then after this, you can write down the equilibrium equation in the vertical direction by yourself as a homework. Okay, don't be afraid. See. In order to do this, we want to simplify our picture because it's too complicated. We only draw the horizontal component here. This one, draw it here. We don't draw the vertical component. This one, draw it here. And this one, the horizontal component, draw it here. Don't draw this. And this one is this one. And this one is this one. Okay? We only take out all the horizontal components. We don't care about the vertical components in this stage. Okay, see now the picture is more clear. At the right hand side, right, arrow stand for right, arrow stand for left. We have the normal stress. Okay, and also in the upper side we have the upper side and the downside, we have the shear stress, okay? And in the middle, we have the body force. So what will be the equilibrium situation? It is simple, very simple. In the x direction, we have this, and then equals 0, 0 here. And then, let us take it. The normal stress here at the right side, subtract the normal stress in the left side. This one subtract this one, and then time the length, dy. Okay, this is the length, dy. Okay, this one give you the resultant force. This one subtract with this one and time dy, like this. Okay, and also another term is this one subtract with this one time dx. This length is dx. This one subtract with this time dx, like this. And this one, what is here? Time dx dy. Why? Because the unit of the body force is usually count by per unit volume. Okay, in three-dimensional case. Now in two-dimensional case, we consider the body force per unit area. So we time dx dy here in order to get the resultant force. Okay, and all this resultant force sum together will give you 0. This is called the equilibrium, okay, state. Now, to simplify our equation, we divided the left side of this equality, the left side by dx dy, the right side by x dy. It doesn't change the equality because we are dividing the left side and the right side by the same amount, okay, of terms. So we get some easy result now. This one divided 0 divided by this equals 0 still. This one still. And this one divided by here, dy will cancel out. Only dx remain. This one comes from here and this one comes on here, and dy cancel out. This term is this term. And this term, dx will be cancelled out with dx. Also only dy remain. So this one right here, dy right here. And bx term, dx dy will be cancelled out with dx dy. Okay, so bx, put it here. And now, this is the stress sigma xx in the right hand side. This is the sigma x in the left hand side. When they subtract to each other divided by dx, we say that it is just the differentiation. Okay? So we have this one replaced by partial sigma xx partial x. We will expand this term, this viewpoint later. And now, this is the, I write it wrong. This is the up. Sigma x, y, u. U stand for up. This is not arrow. I made some mistake. This is not arrow. This is up. Okay? U. Sigma x, y, u minus sigma x, y down divided by dy will be equal to this one. So finally, we can put it this one to here, and this one here, and this one to here, to get the differential equation for the equilibrium state in the x direction. So this picture shows us the equilibrium state, and mathematically we have this relation. Okay. Now in the same deal, we will have the equilibrium equation in the right direction. Okay, and this equation should be derived by you as a homework. Okay. Now I want to explain it to you why this term equal to this one. Okay. Why this one equal this? Let us look at the beam. We draw the material point A, B, C, D here. A, B, C, D. Okay. Now the coordinate in the x is x. At A point is x. At B point is x past dx, right? Here A is x. Ax. Okay. How about B? B is x past dx because the length is dx. Okay. So it's x plus dx. So sigma xxl in the left side will be equal to sigma x as a function of x. And sigma xx right side will be equal to sigma xx at sigma plus dx, right? Sigma plus dx, just like this. Okay, the point, the coordinate, like this. So this subtract to this term subtract with this term will be replaced by this term subtract to this term. This is exactly what we do here. Sigma xxr minus sigma xxl replaced by sigma x as a function of x plus dx minus sigma x as sigma x at coordinate x, okay, and then divided by dx. And now we replace dx by delta x, okay, dx by delta x, and take limit delta x time to 0, tend to 0. Okay, and this one replaced by this, and this one replaced by this. But look at here, this is the definition of the differentiation. Okay, so we can replace this one by the differentiation. But in fact, the stress component is a function of xy, not just a function of x only. So this the ordinary differentiation should be replaced by the partial differentiation. So this one is equal to this. Understand? This is how we get this relation. Okay, in the second remark, we want to draw. We want to write down the three-dimensional equilibrium equation like this. How? Let us look at the rule. See, in a two-dimensional equation, we find out the rule. X, right? X. And then xx, y. Again, we have x in the first index. How about the second index? X, y. See, upper side right, lower side right. Upper side right, x over 6. So we first write down x, and then xx, y. Okay? We generalize this to here. Three-dimensional. X, right? First write down x in the first index. And then for the second index, xx, y, z. And then in this way you can have the three-dimensional relation easily. For the second one, you can do the same job. Second one. First index is y. And then second index xx, y. Okay? So here, first index y, right? And the second index xx, y, z. And then you get the second equation for the three-dimensional equilibrium state. And then for the third equation, you can write the first index as z, and the second index as xx, y, z. And then you are done. Okay? So it is easy.